Hello students, today I am here to solve the next questions, that is 3A, 3B and 3C. So this is our lecture series 3. So today again I am going to use the integration formulas and we are going to solve very simple problems. Stokes theorem, Gauss divergence theorem and line integral we are going to solve. So here we have the first question. Without wasting our time, we will solve it very quickly. So time is very important. Your time is more important. So I'm going to quickly start the example. Please like and subscribe. Yes, this time I want students you to like this video. 35 likes must be there so that I can go for next lecture series 4. So here we have a very simple question. Evaluate integration f into dr where f is equal to 3x yi minus y square j and c is a part of parabola y is equal to 2 x square from the origin 0 0 to the point 1 comma 2. So there are very different types of methods we have. Very simple method I am going to solve today. So here we start with our example solution. Yes friends. So this notes are also available in the link below the description box of this video lecture series number 3, and also you will get the link for the question paper where you can solve the remaining questions one by one. Okay, so here I am going to use this integration f bar dot dr bar they have given here. We have to simplify. Here we can see, first we must know that what is r equal to. R equal to, we always consider this as xi. So here we have only I and j. K is 0, so I will take only xi plus y j students. Okay, so this is a parabola they have given here. They have given y is equal to 2x square as a parabola. So now I will simplify one by one. So when you take this dr, then this will become dr is equal to dxi plus dyj. So here they have given capital I. If you want, you can take the capital I and capital J. So in this example they have given capital only, so we will mention it as capital only. So whatever there in the question, we have to take it as it is. So capital I, capital J is there, so I, J are just the direction. Okay, so here we have dr and we know what is f. So this is our f. So I will just substitute a very simple question. Therefore integration c f bar dot dr bar, we used to take ijk. So I'm just going to take integration f. I'm going to substitute 3xyi minus y square j. Okay, then dr. So dr I'm going to take this as dxi plus dyg. Yes friends, very simple they have given. Now whenever there are I and j, please remember this, that corresponding elements are always multiplied. So therefore I am going to take this corresponding elements. So here I am going to take, this is equal to integration I is with respect to I am going to multiply, j is with respect to j is going to multiply. I into I is 1, j into j is 1. Therefore the simplification of this is a dot product student, so therefore only corresponding elements are multiplied. What are the corresponding elements? It is 3xy dx. That's it. Then minus into plus is minus. This is y square dy. Yes friends, that's it friends. We say this is a simple given equation. Now we put the parabola, because this is a line integral, we directly put y is equal to 2x square. Yes friends, when y is given here, then x limits of x are 0 to 1. So this is a line integral friends. So we always take only single integration. So therefore this is equal to integration x, I am going to take this 0 to 1, and I will substitute wherever x is there, wherever y is there, sorry, I am going to substitute 2x square. So here I have y and here I have y square. So therefore I am going to substitute this here. So this is 3x 2x square dx minus, so y is there, so I am just going to take this as 2x square the whole square. Yes friends, again here differentiation of y is there with respect to 2x square. Okay, so differentiation of 2x square. Yes friends, this is a completely different type of example they have given. Yes, now we can simplify. This is integration 0 to 1. Here I am going to get 3 into 2 is 6 x cube. Okay, dx is common, so differentiation I am going to do on the right hand side. Students, please see here, differentiation of x with respect to 2x square. 2 is constant, so I will take 2 outside, into differentiation of x square, students. So it is 2x, which is equal to 4x. So that I am going to take it in this. So here we have 4x dx. I am going to substitute. So differentiation of 2x square will give you 4x dx. So here I am going to substitute this. So square of the square is nothing but 4x raised to 4, and differentiation of 2x square is nothing but 4x, and the common here is dx, student. So this is how we just simplify. So quickly I am going to take the integration 0 to 1. This is 6x cube, as it is no change, minus 4 into 4 is 16, x raised to 4 into x is x raised to 5 dx, students. If you have time, just put it in the calculator. I already shown how to use the calculator integration in the previous video, and in the description box you will get the link how to use the calculator, and this will be equal to minus 7 by 6. Yes friends, you can put the calculator, you will get this directly answer. This is how we can solve the line integral, friends. So I have solved very simple and direct. I have done the example very easily. This is the next example, friends. Yes, without wasting your time, using the Green's theorem. So like this I am going to solve very quickly and very easily. I am going to solve all the examples. Just I want only one help from you, one support from you, students. That is only 35 likes for this video is required, so that I am going to go for lecture series 4. Okay, so here we can easily see, here they have given evaluate Green's theorem is there. So whenever Green's theorem is there, please see that you are going to do two integrations. So it is a double integration, or we also say this integration is nothing but surface integration. Okay, so without wasting your time, I am going to substitute the values here. Now you can look at this problem, friends. One thing is very simple, that m dx plus n dy. Please remember the integration m dx plus n dy. So let me write that formula. So you should always remember the formula, friends, immediately. Whenever you come across Green's theorem formula and definition I already discussed in the previous video lecture. If you want, you can just go and watch that. So what Green's theorem says, if it is integration m dx plus n dy, yes, it is of the form m dx n dy, you can see in the screen. So this is equal to integration of integration r dou n upon dou x minus dou m upon dou y dx dy. I'm going to use this formula, friends, very easily. You can see here m, they have given here m is equal to y minus sin x and n is equal to cos x, students. Immediately you have to differentiate this. So differentiation of dou m upon dou y will be y, only differentiation is there, 1. Sin x is a constant, because we are differentiating only with respect to y partially, therefore minus 0 I get, which is equal to 1. Okay, then differentiate n with respect to x, I will get this as minus sine x. So only x is our variable. So using this partial differentiation, you will get the video link in the playlist of partial differentiation. Isn't clear, students? Okay, now after simplifying this, substitute in the formula. Yes, students. So therefore I will take RHS is equal to this part, students, RHS. So this is integration of integration. Yes, integration. Now very important, I already discussed in my previous video lecture, that is Green's theorem. So first they have given only x-axis and y-axis. Looking at the problem, we can easily identify this is x and y. So there is one point B. So only one point they have mentioned here. I will consider this some point as B. First they have given y is equal to 0. So the line goes from 0. Yes, friends, it goes from 0 to x is equal to some line pi by 2. So here I consider somewhere here line is there, and this is pi by 2. Pi by 2 means it is 90 degrees. So here y I will consider this as 0 and x is equal to pi by 2. This is the line. Now from 0 to b there is another line. Yes, from 0 to b there is another line which is given by y is equal to 2 pi by x, student. So this is very important, 2 pi by x. So here this all boundaries they have given. Now first boundary is very clear. So this is somewhere pi by 2 is constant. So when I take y is from this condition, so when I take y is from 0 to y is equal to 2 pi x, students. Then another one value they have given x when it is 0, from 0 to x is equal to pi by 2. So therefore we take this 2 integration, students. Please understand this integration. Once again, just repeat the video, you'll understand how to take the x and y. So one thing is very clear, when y is equal to 0, so here you can see, looking on the given three equations, first one, second one and third one, looking at these three equations we can easily identify our limit. So first, always we are going to integrate with respect to y, therefore I say this is y is equal to 0. So two things is clear on from the given question only, y is 0 and y is equal to 2 pi by 2x divided by pi. So this 2 is clear, only x we have to find, means x is pi by 2, upper limit they have given pi by 2, lower limit please consider it as 0. So x is here 0 to pi by 2 from the given equation itself. Now substitute the values. Yes, friends, dou n upon dou x is minus sin x, so I'll just substitute here minus sin x, then minus dou m upon dou y is 1. Then first always interchange this dy and dx. Yes, students, in my vector integral playlist I have already given how to change this dx and dy and when to change and how we simplify this example. This type of examples I have already done. This is a examination question paper video lecture series number 3. So therefore I am simplifying this now one by one. Now this is equal to, yes students, now first I will simplify with respect to y. Wherever y is there I am going to take the integration. Looking at this question, there is no y in this, so therefore I take this as directly the constant here So first y is equal to 0 and y is equal to, here you can see there is no y in the equation, therefore x is equal to 0 to pi by 2 minus sine x minus, just a minute, minus sin x minus 1 minus sin x minus 1 will become constant, so I have taken it outside. Integration y 0 to 2x upon pi 1 into dy dx. So because there is no integration, therefore I have taken here 1. There is no variable y, therefore I have taken 1. Integration of 1 is y. So therefore this is equal to integration x 0 to pi by 2 minus sin x minus 1. Integration of 1 is nothing but y. In the limit y is equal to 0 to 2x upon pi. So this term I am going to substitute here, students. So now first I will take the upper limit 2x pi, and here please see y is equal to 0 is 0, so there is no point of taking y is equal to 0. Only upper limit I am going to substitute 2x divided by pi. So therefore here this is equal to integration x 0 to pi by 2 minus, I will take it outside so that our simplification will become very easy. Minus is outside, sin x plus 1 I will get here. Now y is going to become 2x divided by pi, and this is dx. So constant I will take it outside, 2 divided by pi outside, minus 2 divided by pi, integration x 0 to pi by 2. Now I will simplify this. First I will take x as it is, and this is going to become sin x plus 1 dx. So looking at the equation, it is very clear that first it is u into v rule. Please go to the integration formula, or you can just watch my previous video in the playlist. I have given integration of u into v. In the integration of u into v, I'm going to integrate this 2 upon pi as it is, no change, students. First I will take x as it is, yes, u as it is, integration of sin x plus 1, it is going to become minus cos x plus integration of 1 is x in the limit 0 to pi by 2. Next, minus integration 0 to pi by 2. Now differentiation of x is 1. Yes, please listen properly. Differentiation of x is 1, and integration of sin x plus 1, it will be minus cos x plus x dx. So this is equal to integration, yes friends, again this is minus 2 upon pi, this is in the limit 0 to pi by 2. Wherever x is there, this is 0 to pi by 2. I am going to simplify this, friends. Yes. So now first I will take pi by 2. So x is pi by 2, this is pi by 2. Is it clear? Then minus pi by 2. Yes, friends. Cos 90, you can just put it in the calculator. You will get this as 0. So therefore I will not take this. Only I will put x pi by 2. So therefore this is again pi by 2 minus 0. There is no point of 0. 0 is 0 only because x into minus cos x plus x. You can see this is going to become 0. Thus full things is going to become 0. So I am not write that 0 minus. Now again I am going to integrate this, friends. Integration will become here minus is there, minus cos x. So when you integrate this, it is going to become sin x. So therefore I will take this as minus sin x plus, yes, integration of x is going to become x square upon 2 in the limit 0 to pi by 2. Okay, so I'm going to put x is equal to 0 to pi by 2. This is equal to, students, minus 2 upon pi, as it is, no change. Pi by 2 into pi by 2 is pi square divided by 4. Then minus is plus. I'm going to take this minus here. Sine pi by 2. Yes, students, you can put it in the calculator and you can find out very easily what is sine pi by 2. Yes, students, it is 1. So therefore I'm going to consider this as minus 1. Then this I'm going to substitute now. Pi by 2 the whole square, pi square upon 4 I will get. Yes, friends, I'm going to substitute x square as pi by 2, so therefore the pi square upon 4 I will get. 4 into this 2 is going to become 8. Therefore I will directly write this plus pi square upon 8. 0 is 0, both terms are 0. Therefore I am going to take this as 0 itself, friends. Now, yes, minus is there here, minus 2 upon pi is there. You can take it inside this bracket, friends. So therefore minus 2 pi square upon pi into 4 will remain. Minus into minus, so I have multiplied this in this and then this to this bracket. So minus into minus is going to become plus 2 upon pi, and this is minus 1 plus pi square upon 8. Then if you want, you can simplify this, friends. So this is equal to minus, yes, now you can see 2 1s are 2 2s are 1 pi will get cancelled. Therefore this is minus pi by 2. Yes, friends, minus pi by 2 plus 2 upon pi. I will take it inside the bracket, so it will be minus. So this term is going to become minus 2 upon pi. Then this is plus again 2 pi square upon pi into 8. If you want to simplify, 2 1s are 2 4s are, you will get 1 pi will get cancelled. Therefore this is minus pi by 2 minus 2 upon pi plus pi by 4. Yes, friends, if you want to simplify, see, this is minus pi by 2 and minus 2 upon pi. If you want, you can simplify this and you will get this answer pi by 2. So this is pi will get minus pi by 2 plus 2 upon pi minus 1 plus pi square upon 8. So this is your answer. If you want to further simplify, this will be equal to minus, I will take it outside, pi by 4 plus 2 upon pi. So this is our answer, students. So here you already completed the answer. If you want, you can simplify, or it is not required, students. So this is how we have to simplify all the questions one by one very easily, students. So immediately we'll go to the next question. Very easy and very important question I'm going to solve now. Yes, next we will go to the next question, where they have given evaluate the integral. So here the next question they have given evaluate using the Stokes integral. So integration C x plus y dx plus 2x minus z dy plus y plus z dz, where you can see they have told where C is the boundary. Yes, friends, without wasting your time, quickly simplify the problem, substitute the values and get the answer. So you should be very fast, students. So in a triangle they have given the vertices here 2 comma 0 comma 0 comma 0 comma 3 comma 0 and 0 comma 0 comma 6. Yes friends. Okay, this is the question they have given. Okay, let us see what all things they have given. In the Stokes theorem, please see that you come across the curl of f and it will be a determinant. Yes, we are going to solve with using determinant. So without wasting the time, f is equal to, write down, yes students, f plus x plus y I plus 2x minus z j plus y plus z k. Okay, so next, immediately whenever you come across Stokes theorem, we are going to find the curl of f. Okay, so curl of f runs, take this as I, j and k terms, where we get this as dou upon dou x, dou upon dou y, dou upon dou z. So f1, f2, f3 you already discussed. If you want to know, you can go to my playlist of vector calculus where I have discussed curl of by finding. So using the determinant, please try yourself friends, very easy this is, and determinant will give you 2i plus k. Yes friend, determinant you already come across so many times, so you get this as 2i plus k. Now in the question they have clearly mentioned that vector n is normal to this plane. Yes friends, so you can see, if you look at the question, they have given the vector normal to the curve, so there you can easily write the value to the normal students. You are going to find the normal in this case. Now you have to write down the formula for normal and find out the equation students. Okay, so now write down the Stokes theorem. Yes friends, please write down the Stokes theorem formula immediately. So here we have integration of integration curl f bar dot n cap ds. Yes, Stokes theorem says what? If you take any integration here, so you will get the value as integration f dot dr will be equal to, yes friends, it is integration of integration curl f bar dot n cap ds. Now looking at this curl f bar, so I'm going to substitute the value here. This is integration of integration curl f bar is nothing but 2i plus k, 2i plus k, and you can see n cap ds. Yes friends, n cap ds they have mentioned here, which is nothing but the unit vector, this unit vector formula you come across, n cap is equal to del phi or del f divided by modulus of del f phi. So using this formula you can find the value very easily. Here del f, del cross f, I'm going to take this as f1, f2, f3 only, divided by whatever the modulus is there, we are going to calculate here students. Or there is another very simple method you can simplify very easily, that n cap dot ds. Yes friends, n cap, I'm going to take the unit vector where you get this unit vector as, so I'm going to substitute the value directly from the normal vector. So here del phi, you have to first calculate what is del phi students. To find the del phi, we have the equation to the plane through ABC. So they have given here one plane. So let me show that plane where they have given. Yes, so here is the plane they have given. They have told that this 3 is going to become a triangle, where this is, if you take x-axis and this will be y-axis, this is z-axis. At point this I will take a 2 comma 0 comma 0, and at point y I will take b 0 comma 3 comma 0, and at point z I'm going to take c 0 comma 0 comma 6. So here very easily we can calculate what is n cap students. So n cap you can take here, it is area of triangle ABC. Yes friends, so it is the area ABC it is going to become an area ABC. So therefore n cap I'm going to simplify in this way. So n cap is a normal, therefore with respect to x-axis this is 2 is there, x is 2, and with respect to y-axis y is 3, with respect to z is equal to 6. So in simple I say that this implies x upon 2 is equal to 1, that implies y upon 3 is equal to 1, that implies z upon 6 is equal to 1, or we say x upon 2 is equal to y plus y upon 3 plus z upon 6, which is nothing but equal to 1. So when you simplify this you will get this as 3x plus 2y plus z is equal to 6. So you can take the LCM and you can find it very easily. Then you can take the normal to this n cap. So this is our phi. So then you can take the n cap is equal to del phi. So this is going to become our phi value students. So phi divided by mod of del phi. Already I have discussed how to find the unit vector and all. You can easily go through the previous video. Here I will take 3i plus 2j plus k divided by root 14 students. Okay, so this I am going to substitute in this equation. Okay, now this will be equal to n cap ds is going to become 3i plus 2j plus k divided by root 14 ds. So now corresponding elements are multiplied. This is the dot product 2i is multiplied to 3i only, so it will going to become 6. So 14 root 14 is constant. I'll take it 1 upon 14 outside. So then this all terms, yes friends, you can see this all terms are only ijk, it is a constant. Therefore this integration with respect to c is going to give you with respect to s. So 2i is multiplied to 3i is going to give you 6 plus here j is not there. Yes friends, when j is not there, please j into j we cannot do, therefore this is going to become 0. Only k into k is 1, so k into k is going to give you 1. So then integration s ds. So because from this c we are going to consider this equation, yes, so only one variable is there, that is s. So there is no other variable. So therefore this is going to give you 7 divided by root 14 into integration of s ds. Yes, integration of s ds is nothing but the, already I told you, it is nothing but integration of s ds is nothing but some area and covered under in the triangle ABC. Yes, students. So now when you find the area under this, you can easily find what is the modulus of this: x upon 2, y upon 3, z upon 6. Yes, students. Easily you can say that this is 3 root 14. Yes, students. Area under this curve, you can take length into breadth, 1 upon 2 length into breadth. We can easily find that area, or this is just root 14 is a plus root 14 b plus root 14 c. Therefore this is 3 times root 14. Now you can just substitute in this. It is going to give you 3 root 14, which is equal to root 14. Root 14 will get cancelled. 7 into 3 is 21, students. So this is how we can easily calculate the value. Yes, students, if you like it, please like the video. If it crosses 35, students, I'm going to go for the next video. Yes, students, thank you so much.